Now, let's go ahead and do this graph. And for this one, again, we're just going to make a table right here, just like this. And what do we got? About 5 values in there. I think that's pretty good. Now, of course, you'd usually want to start with your y-intercept because working with zeros is a pretty easy thing to do. And instead of doing f of x here, I'm going to just use y. Now, it should be x squared plus 3, right? That's my equation. But now I have chosen a value of x that I'm going to find the corresponding y value for. So putting this into the calculator, you should just get a y value that's 3. And that would give you this ordered pair right here. Next value, of course, that I'm going to choose is 1. I'll use an x value that's 1, so that's going to be y equals x, but now it's 1 squared plus 3. That's going to give me a y value that's 4. And if you're not sure how that happens, just plug that into the calculator and get your y value. So I've got 1, 4, which is going to put me right here. The next value that I would use is 2, so that's going to be y equals 2 to the power of 2 plus 3. And that would be 4 plus 3, which is 7. But again, you can use a calculator. This one, even though I don't have that on the graph, you know, I could do that by hand, and it's approximately right there, just so that my graph looks decent. But I'm off the graph, which means I'm going to go now to the left for my x values. So the next x value that I'm going to use is a -1. So I have a -1 for my x, y equals -1 in parentheses to the power of 2, which you should put into the calculator. And that's going to give me a y value that's 4. Now, I should have expected a 4 right there. Okay, so that's going to give me this point. Why would I expect a 4? Because there's something called the axis of symmetry that goes straight through. This is called the vertex, which for this particular parabola is the very bottom point of that parabola. Meaning that if I were to draw that axis of symmetry right here like this, the points are directly opposite from each other. So for example, this one that we found, which was 1 unit to the right of the axis of symmetry, it has a reflected point that's 1 unit to the left of the axis of symmetry. Same with the red point, which is 2 units to the right. So it's going to have a reflected point 2 units to the left, approximately right here. Which means if I used an x value that's -2, I would expect a corresponding y value that's 7. We can confirm that by putting this into the equation, right? So I could say -2 to the power of 2 plus 3, and the -2 does need to be in parentheses there when you put that into the calculator, but yes, you're going to get a y value that's 7. Now, you don't have to know about the axis of symmetry for this class, but it may help you, especially when you get into 1010. And our parabola should kind of dip in here, you know, something like this. In any case, I'm just going to start from my vertex. And then let's see if I can draw this one decent. That looks okay. Now, that's not a great job, but it's decent enough that I think it's going to work. And again, I have a table. I've got a table over here. I've got a lot of work to show for it that kind of proves that, yeah, I know how this parabola happens. There is another method that we use, but you'll have to watch the next couple videos for that. So thanks for watching. That's it for this one.